Okay, good afternoon, good evening to our viewers. My name is Dr. Chitrani Majumdar, and on behalf of Remote Sensing and GIS at AIT, I welcome you all for our second session of RSGIS webinar series. In this session, we have a technical session followed by an interaction session where we will address some issues and questions also raised by our audience. Our main speaker today for the technical session is Dr. Hiroyuki Miyazaki, who is a seconded faculty at RSGIS from Japan, and also a project assistant professor in the University of Tokyo. He has expertise in geospatial technology in application fields such as environment, disaster management, urban infrastructure, and public health. We will hear more about his specializations and research interests during his talk. We also have today Dr. Bhoj Raj Ghirmire, who is our PhD alumni and currently an assistant professor at the Nepal Open University. Thank you, Dr. Bhoj, for joining us today. So, So before we head on to our technical session, probably may I request you to briefly share your experience at AIT and your current involvements in Nepal?
Yeah, thank you. Thank you, Dr. Chitrani, AIT team, along with Dr. Miyazaki, for inviting me in this talk show. As you have mentioned, I'm Bhoj Raj Ghirmire, a PhD scholar in AIT Remote Sensing and GIS field study from 2014 to 2018 back then. Currently, I'm working as an assistant professor at Nepal and program coordinator at Nepal Open University. It's a national, it's the only open university funded by nation in Nepal. Though I joined the PhD in late 30s, living my mid-career in Nepal, it was really an awesome experience in AIT. Being an AIT means somehow you are already into more than 30 countries at once. In a very small boundary of AIT, you can experience the culture, the food, interact with the people from different parts of the world. It's AIT is really a small global village in a true sense. So I miss those days that I've spent in AIT. Of course, learning Taylor series and long advanced calculus after more than decades of my study leave was not that easy, but learning was really cool. The professors were really friendly, and we had good research experience over there. Moreover, apart from being an AIT itself, it provides you a tremendous opportunity to travel abroad from AIT. Even in my case, most of my research work was performed in Japan, and there I think I got a Japanese flavor of dedication and hard work that still I'm selling these days, I would tell. So most importantly, I think I have gained confidence from almost 4 years of my stay in AIT. The rest we'll be talking later.
Okay, thank you so much, Dr. Bhoj. It's always overwhelming to be in touch with alumni like you. So now may I request Dr. Miyazaki for his technical session and enlighten us with the current topic. To the viewers, if you have some questions, please feel free to write your questions in the chat box in Zoom and comment box in the Facebook Live so that we can address them during our interactive session later on. Over to Dr. Miyazaki. Thank you.
Okay, thank you very much for this opportunity, the sharing my experiences and expertise through this web webinar. As I have introduced, I've been the seconded from the University of Tokyo and to the RSGIS, and since the 2016, so I have stayed 4 years. So let me quickly introduce myself. So since after the acquisition of a PhD degree in the University of Tokyo, I had been in the Asian Development Bank with a mission of the promotion of geospatial technologies and the space technologies in the development projects in the Asian Development Bank. So that was a great opportunity for me, extending my the researches to the how to make the people happy using the geospatial technology. Originally, only the remote sensing for the urban growth, but now I am working with the various fields. So that's great. And also not only the research or academic. Recently, I have much interest in how to extend the outcomes for in practice, such as the businesses. So now I have several technical partners for the working the researches and outreaching the outcomes to the practices which makes the people happy. So let me move to the sound. Because this is an open seminar, very introductory about geospatial technologies. So if you, some of you from the RSGIS, but probably the better to share, give the assumption about my the background. So the geospatial technology is with information, with location information. So that it is typically the latitude, longitude, not only the coordinates. It is sometimes with the address or the elevation, etc. And there are so many the sources of the geospatial technologies. Because it takes the something or objects in the real world. Most of the objects in the real world could be the geospatial information. The geospatial technology is a technology handling and managing and processing the geospatial information, such as maps, satellite data, sensors, ground field sensors, mobile phones. Now everyone uses a mobile phone or smartphones, and also some other Google Maps, Google Street View cards or mobile mapping vehicles. So I am going to talk about this kind of technology, how to the use for the sustainable development. So here's the list. I am going to talk about the satellite Earth observation, people mobility data, and also the geospatial technologies for the community resilience. So the sustainable development primary question, where people living. Because sustainable development aiming to basically to the people, we need to know where people living. So this is the primary the question. So let's see the Earth on the Google Earth. The Google Earth is very useful to identify where people living. The Earth you can zoom into the specific areas, and we may identify where the buildings, how is the road extensions, how is the forest, or how many buildings are there. And then you can estimate how much is the scale of the urbanized areas. And then you may estimate how many people are living there. So just a satellite photo or satellite observation provides you much information about where people living. So there's a voluntary activity is mapping the ground objects or the infrastructure, buildings, roads, etc. From satellite data. The Microsoft Bing Map service that provides high-resolution satellite imagery for the mapping the ground objects by OpenStreetMap. Owing to the OpenStreetMap, now everyone can access to the geospatial data or map data for their study or the operations in practice, specifically for the disaster responses, which requires planning in the logistics for the humanitarian assistance, humanitarian aid. However, this have been operated by manual interpretation, visual interpretations. So it takes a very long time, the updating the global scale. So while now the world is changing, the manual operation cannot catch up the changes of the world. So that is the motivation, the automating the mapping. So recently, the deep learning or machine learning is a buzzword, specifically for the automation of some processes. So the satellite, the mapping using satellite data, this is the potentially the useful the potential field applying the deep learning, specifically for the mapping the ground objects such as a building. So my research group already established how to apply the deep learning for the satellite data mapping the ground objects. And also recently extended to the automated the mapping systems use of the satellite data. Now that it's ready to the mapping the broad scale, such as we can have the map of the buildings, so for a specific whole of the nation. For example, I am now working with the Mozambique in Africa. By use of the high resolution satellite imagery in the 2.3 the spatial resolution. So this is an example of around the Maputo. The red pixel or the red area is automatically the map to the buildings identified by machine, not manual. So let's close up into the cities. So this is an example of the automatically identified buildings, building segments by the machines. So you may see that every building, some buildings still drop, but most of the buildings were identified with shapes and the size. And also this could be extended to not only the urbanized areas, it's also extended to the suburban or rural areas. So this kind of the information useful or for monitoring the urbanization, where people living again. And also specifically for the broad scale or in this kind of, for example, in the African country, they have the quite large land in the nations. So the nations the suffering malaria or some other the public health issue. So it is important for the government or health agency identify where people are living, because of the location of with the population is could be a hub or the transmit for the extending of the communicable of the diseases. So I have been working with some medical research institutes, giving the maps for the broad area to identify where people living. Even in the smallest villages, sometimes critical for the controlling the communicable diseases. So this is an example of the nationwide the mapping of the buildings in the Sri Lanka. This is 2 years ago, the output. At that time, still some issues, you might see the blocky the areas failed to the well mapping. But to in this the output of this is you can see some of the grayscale images which likely showing density of the buildings. So as I have mentioned, the building is primarily the information, the mapping the demography. And based on this kind of the information, we can also getting the detailed information about the demography. With the recent geospatial data, the 100-meter grid the population data developed by WorldPop, that is the highest one, but it could be also the downscaled to the higher spatial resolution, such as the 30 meter. So this is an example, the use of our methodology, the downscaling of the population data into the building scale. So now that we can see the population, how many people living in every building. So for this kind of the methodology could be extended the whole globally. As we have so much the satellite data archives so far since the 1972. So this historical archives also helpful to see the urban growth or the how to also, in addition to the past urban growth, we can see the future growth, which is the important the baselines for discussing how to keep the sustainable development. In the past, this kind of satellite data was expensive, and also the taking time for the getting the data. Even now, regardless of the internet, the data size is growing. Some data set takes the 1 gigabytes or the so much gigabytes. We cannot take some countries which do not have the good internet connection may take time for the use of the benefits of the satellite data. However, the recent data infrastructure, the directly connect the data store and the data processing and data visualization. Then we do not have to download the massive data size. Even this is the good platform for everyone to work on the data analysis of satellite data. Example for I worked for the ADB, Asian Development Bank, mapping the urban growth for using the past the data looks like this: the 1994, 2006, and 2016, and then based on the urban growth trends, in a way of the probability or the stochastic or the approaches, we can estimate or predict how much is the urban growth will be in the future. We cannot predict any accurate prediction. However, this should be with a scenario. In the case the government do not have any control, then some city area could be flooded in severe disasters. So this kind of historical data will be useful for the future prediction in a scenario. Then with the baseline, the government and the people may develop the plans and strategy for the sustainable development future. And in addition to this kind of the land or urban growth data, these are another sources. The sources for the urban growth or the urban activity or socioeconomic activities, the nighttime light. NASA provides the data every day, how the nighttime light of the cities looks like. This is an example of the Bangkok city, which is the brightest area around the Southeast Asia. So because this is taken every day, we can see how the brightness of the city is changing. For example, recently in the last half year, we've experienced the COVID-19 crisis, and some cities heavily lockdown. That is appeared as the impact of the nighttime light. As there's people coming to the business center, the light should be reduced. This is an example of how the nighttime light looks like around the Tokyo and Osaka, Kansai in Japan. Around Tokyo, the emergency, state of emergency was issued in April. So you might see around April, there is a significant reduction of the nighttime light, which means that the city, much less active in the socio-economic activity. Actually, there was so much impact in the shopping or some other industries. This also could be useful. How much impact of the impact of COVID-19 or the disasters for a city. There's an example of the Bangkok and Wuhan. In Bangkok, the state of the emergency was around the end of March. We can see the much reduction of the city light around April. While the Wuhan had some reduction in the January to February, and then it recovered earlier than the other cities. However, Wuhan had the disaster, the heavy rain around June. So again, it is get darker in June again because of the disaster. So these kind of the data also archived. So this is also good for the monitoring the urban growth by comparing the historical data. This is an example of the monitoring, observing the urban growth the 20 years between the 1992 to 2013. You may see that some cities rapidly extended, while the other some cities less do not have the much expansions. Also, these kind of the nighttime light is often analyzed with the correlations of the GDP or electricity consumption. Then these kind of the data are used for monitoring the changes of the socioeconomic activities in the city. So again, this is I am extending the where people living to the where people active. Or this kind of the data are very useful for the planning and strategies of the sustainable development. So I have talked about the satellite data. Now let's move to the another data source, people mobility data. So when you use the Google Maps on your smartphone, when you opt in the location history, the services, your locations always recorded and then stored in the private cloud of Google. You can refer where you were at a specific time, and like this, using the Google timeline, the location timeline, the functions. So this is just my private or personal data, but actually everyone, it's the thing of everyone can have this kind of data. And not only this kind of the data, just a mobile phone is an important data sources, the call detail records. When you call or text or data communication, your activity on the phone is recorded by mobile phone operators, originally for the billing purpose, but every record is also recorded with which cell tower you used for the activity. So by use of the data, your location could be identified by the location of the cell tower. So there's some preliminary pilot use of the data, the visualizing the people mobility. In this the video, the purple is the cell tower, and the blue dots are the mobile phones. Along with the time goes, you can see in the clock, this is the useful in daytime where where of the city is much crowded and which route the people are taking. So this kind of the data is useful to see the dynamics, the dynamics of the population in a day. So my colleagues in the University of Tokyo have been working with the use of this kind of the data for the demography mapping. So when you this kind of the data is useful for the estimating of the some personal profile. For example, the student take a route every day between the home and the school. In the morning or going to the school, and in the evening go to some shopping and then come back to the home. While the other for example, home workers may stay at the home whole of the day, or then this kind of trajectory, people's trajectory useful identify so the profiles. Then the census, usually the census took every 10 years, but now the world are changing. it is impossible to take the census, national census every year. Instead, this kind of the data sources useful to the estimate the how the demography changing, the supplementing the national censuses. Also, the urban traffic is the issue. In Bangkok is the world's worst city about the urban traffic, and I have been working with some of the projects on the urban traffic in Bangkok. So some private companies operate the GPS logs of the taxi or the commercial vehicles. This kind of data is useful estimating how much the speed of the traffic. Also, it could be useful which is the most active in the cities. So there is a JICA project, the Smart Transport Strategy for Thailand 4.0. The urban transport is not only on the road. It actually relevant to the urban land use as it is much impact in the commuting patterns of the people. So for this kind of the study, the GPS logs that I have shown, or the people mobility data, they're very useful for the monitoring or the understanding how the people moving place to place as a pattern, and then incorporate into this kind of a strategy. And the other example is some of the regional connectivity analysis. I am skipping the detail of this study, but you can find the report from the website of IDE JETRO. The last one is about the geospatial technologies for the community resilience. So the smartphone, I have been studying about the geospatial technology for the disaster risk management. And recently, I am thinking the smartphone is a really the breakthrough technology for the disaster response, as it has very small devices can have the communications, camera, and the positioning, which are very useful in the disaster responses. So I have worked in the Nepal, giving some of the capacity, the development, use of the smartphones or ICTs for the disaster responses, more focusing to the disaster nursing together with the Nepal Nursing Association. So for nurses in the disasters, the question, where the people need their help. Also for the people or the disaster affected people, they want to know where they can have the humanitarian aid. Or in the medical situations, or the normal situations, it is okay to take the call or request by phones. This is okay for the normal situations. However, in the disaster situations, it's flooded. Many requests comes at a time. Then the medical or the rescue team cannot have the good decision where to go first. So then I have been working how to manage this kind of the needs, information about the needs from the people in the disaster situation. So this, as you might see, the Nepali in this slide, this is given to the nurses in the Nepal. So that it is also some basic. So the smartphone can take the photo, useful for the collecting the granular information, which has a very detailed information. While we can extend those information to the bird's view, the good for the planning, the strategy, and also the management of the infrastructure, especially in the large scale the disasters. And then the combination of these is very important for the complementing the advantage of each other. So I have been working how to incorporate these the benefits, specifically for the collection of the information from the people. Again, the smartphone is really a breakthrough for this issue, because now almost everyone that has a smartphone, and easy to contribute to the data collection for the disaster responses. And also now the cloud technology much penetrated. In the past, there are many scheme or the databases for the disaster responses, but so then the data transaction, compilation, the transaction is the nightmare. While we can just have a single server or database management system for accepting everyone's collecting the information and data from everyone. So this situation could be improved to like this. Once we have the single shared platform which is accessible for everyone, we do not have to compile the information from many sources. Instead, just leave it in a single place, and then this is easy to show it as an overview. Looks like the maps. And because of the platform can be shared with the others, medical team or humanitarian rescue team can easily to coordinate with the others. For example, in this picture, medical team can identify a place where to go first. In coordination with the medical team. So this kind of the information is useful for the disaster responses. The reason I am the community resilience. This is the information data collected by people. So this is enhances how the community is. We do not have to wait for the data or information from the government. We can take the data and the information for understanding how the local community is in this situation. That's why this could be contributing to the community resilience for sustainable development. Okay, so I have talked about these technologies and possible contribution to the sustainable development. And also, I'd like to conclude with the overview about the geospatial technology for sustainable development. So I have introduced about some space technology, Earth observation, satellite positioning, such as GPS, and also in this the lecture, I didn't talk about the satellite communication, but important infrastructure in the space. So these are connected on the ground through the internet, such as the IoT, the mobiles, and also we have some platforms with the satellite data, computing the systems, resources, and also the shared platforms. So once these could be connected, we can access to so much the information resources, and then better to responsive to the changes, and then the sustainable development could be achieved. So this is the last slide that I wanted to talk about. Thank you very much for your kind attention.
Thank you very much, Dr. Miyazaki, for covering a vast range of topics, I must say, within such short period of time. And I'm sure our viewers also have enjoyed thoroughly the entire session. Now let's move to our interaction session. I see that there are some questions probably in the Facebook Live comments. Viewers, if you still have some questions, you can still post in the Facebook Live or Zoom's chat box. But before that, maybe I request Dr. Bhoj to jump into our discussion probably on the topic, to share your contribution and ongoing involvements towards geospatial technologies for sustainable development.
Yeah, thank you, Dr. Miyazaki, for really comprehensive presentation and covered really vast variety of topics within a short time. Really appreciable. Just to show my lifeline after I left AIT, just going through a few of the punchlines of that. So immediately after my graduation, I joined the International Center for Integrated Mountain Development, ECMOD, a regional subcontinental organization as a GIS specialist and work in the agricultural domain, where I devised application for drought monitoring and prediction system usable for the South Asian region. Of course, that adds to sustainable development goal, zero poverty or something, and hunger. Few SDGs are related to this type of applications. Then I joined Nepal Open University as a assistant professor, and there I have been a program coordinator for 2 postgraduate programs. Then one more thing I did in Nepal Open University was I started a new course, new program called Masters in Geoinformatics, which was not there. None of the Nepalese university used to teach geospatial technologies in master's program so far. So I initiated that program, and currently 2 more universities have started it. And for both the programs, I've been one of the resource person for them. So this is all, the credit goes to AIT, where I learned the curricula and then the knowledge that I learned here applying them. I've been the consultant to Nepal government and many municipalities for the usage of geospatial technologies for better and good governance, I would say. Currently, apart from other things I've been doing, apart from teaching job I've been doing, I am currently working on the development of a integrated municipal information framework, which uses a lot of geospatial technologies and data for numerous governance activities like revenue projection, project progress tracking, municipal level GDP, GIS-based tax projections, and a lot of other things into it. So right now the prototype is already completed, and we are working on the development front. I can see all those activities that I've been doing is closely related to the SDG number 1, no poverty, SDG 8, decent work and economic growth, SDG 9, industry, innovation and infrastructure, and SDG 11, sustainable cities and communities. So at least I've been working on those cross 4-5 different SDG goals. The activities that I have been performing right now are related to all those SDG target 2030. Yeah, this is my some of current involvement in this period. And one thing I just want to share more is mostly geospatial technologies can be more helpful in setting the goal rather than achieving the geospatial, the sustainable development. Rather than achieving it, it's more helpful in setting the goal and then monitoring and evaluation whether these goals are properly set, the works have been properly done or not, whether the development that we have been doing is not on the cost of the environmental degradation, not in the cost of other sort of disturbance in the human life and all that. So I see a lot of the scope of geospatial technologies in helping achieving the sustainable goal rather than directly contributing to the SDGs that we have. So finally, I can see that this can be very much helpful in taking data-driven decision on the real time. Yeah, unless other more questions, I'll stop it.
Yeah, thank you. I think we should look forward for more collaborations, Dr. Bhoj, although you left from here, right?
Of course, always happy to do that. Yeah. It's my pleasure. In fact, I'd be proud to do that.
Yeah, yeah. Okay, so we have some questions in our Facebook Live to Dr. Miyazaki's presentation. So first, probably we take them. I have a question regarding to the data source for nighttime light that you have used, that you showed in the presentation. Nighttime data source.
Yeah, you can find search the keywords nighttime light, NASA.
NASA. Okay.
NASA. Yeah. It is from NASA.
From NASA. Okay.
Publicly available.
Yeah. Then one more question. What kind of method and satellite data is suitable for classifying rural areas which is not crowded?
Classifying rural area, does it mean probably it means the very rural, moderately rural, or etc.?
Like for instance,
fair
most of the provinces cannot classify using NDBI and BI indices. That's the question.
Yeah, そうやな。だから、for my view, specifically as a human geographer, I might the classify the first land cover or land uses, primarily the information, but how network, the road network in rural area, the road network is very important. How much it contribute to the regional economy. So that I might, in addition to the land use or land cover, which are identifiable from the satellite observation, I could add one more, the road network and the people mobility.
Yeah, I would add to that.
Yes.
Yes, as you told, of course, NDVI or BI Business Index would not be that much helpful in the first go. As Dr. Miyazaki just suggested, I would also suggest you to go with the supervised classification, checking the samples from different places, and then first go for the land use land cover classification first. And then after the land use land cover classification, where you get a little bit of urban area, then go for the other layers, as he suggested, the road networks, or maybe the density of the house over there, and some other things can be a determining factor.
Yeah, so we'll wait for more questions if they are. In the meantime, I have a few questions for both of you. So geospatial technologies, as Dr. Miyazaki was also showing, that there is abundance of data, there's abundance of algorithms and tools available. So please provide your suggestion how to use them more intelligently, sufficiently, and fast enough.
Okay.
Yeah, Dr. Miyazaki first.
Okay.
Yes. Okay.
Thank you. Interesting question.
Yeah.
And yeah, the data is just a data. It needs to be the interpreted information for use for benefit for the benefits. So the geospatial data is always location specific. We require local knowledge, the issue, how to work with the local people. That is the intelligent way for the utilizing the geospatial data, massive geospatial data.
Yeah, Dr. Bhoj, your opinion?
Yeah, I second your idea, Dr. Miyazaki, and then I would add a few more things, not to repeat what you have told. In addition to that, I would suggest the choice of most influential or effective data, because we have a lot of data, tremendous amount of data. So which data source you choose is crucial to the type of information that you will get out of it. Next one, use of machine learning algorithms and AI technologies. Even earlier we talked about it in this presentation. And of course, use of programming technologies, programming languages for quick analysis and efficient result. It helps data-driven decision taking, and it allows us to perform what-if analysis, what-if type of analysis in a very no time, in very limited time. We can change the parameters and quickly say, hey, what happens if we do this? What happens if we change this parameter? Something like that. Visualization is quite easier if we go ahead with some programming techniques on our end. Yeah, that's it.
Okay, so in continuation to that, because you talked about machine learning and stuff, so and also I think Dr. Miyazaki also showed in several instances, and this will be like from a student perspective, like how do you think these three are related? Geospatial technology, data science, and sustainable development, these three terminologies. And how do you think the current generation or current students should be skilled? Should they get a degree in, say, geospatial technology or in data science, or a combination of both probably?
Okay, so
yeah, Dr. Miyazaki for a second.
Thank you. As I have told, the geospatial data is location specific, and it requires to interpreted by some data scientists. So for now, data scientists or AIs engineers are mostly gathered in the specific places, specifically for the established the countries or the cities. However, in the case we have the data scientists in everywhere, we can have the much faster the analysis of the data. So we should have the local scientists more. And then once we have the local scientists, there might be the new economy. Then go to the sustainable development. This is my concept.
Yeah, Dr. Bhoj.
Yeah, maybe my turn. Okay. So, as far as the relation goes, I would start this way. Like geospatial technology, of course, deals with multiple layers of information over the same location. That provides us multi-dimensional, heterogeneous time series, big data for a particular place. So with this thing, the strength of data science now comes into picture to mine the most relevant information and identify the pattern, identify the pattern out of this data after mining it. Then with these techniques, it helps us to formulate, plan, execute the action, and maybe monitor and evaluate the outcome to see whether the development is sustained or not. So this sustainable development, geospatial technologies, and data science are related in this fashion. And for the prospective student that you asked, I would suggest to harness at least one programming language and a database technology, preferably Python or R in the programming side, and Postgres on the database side. Google Earth Engine, it can be another tool that I really recommend to learn. It's a cloud-based data processing engine and platform that really doesn't need us to download that GBs and terabytes of data into our machine and then run on our own. So I would suggest the prospective students and researchers to be prepared on those areas. Then degree is another thing that is always good to have.
Yeah. Okay, thank you for the answers.
You were okay.
I just want to inform you, I think during Dr. Bhoj's time, it was not there. So now we have like in remote sensing, like we have in AIT, this is a new transformation that you can get a degree in say remote sensing GIS with a minor in say in another field, say in data science or in computer science, or even you can basically mix 2 or 3 programs now. So this is something new that
great.
Probably it's something like combination of 2-3 programs.
That's really great.
Yeah. So let's go ahead to the next question that we have in Facebook Live. How to get real-time GPS data from mobile phones? As we are work for conservation and we want to track the mobile phone in protected area.
I didn't just say the real time.
Okay.
Sorry, but if we want to have a real time the tracking of data, possibly the long range the communications might help. I think for now I don't have the good idea. The collection of the real-time GPS logs. Dr. Bhoj,
okay, I'll take to that. I think there are 2 approaches. First one, as you told, Dr. Miyazaki earlier told his real-time working data that is provided by Google, but it cannot be extracted. It's only a view-only mode that you can track your data, their mobility there in your smartphone, sync with your Google ID, but that cannot be viewed. That's one thing which is only for your own history. But another way, we have to do it by some tools. There are free tools available. For example, one of the best tools that I have been using is ODK. ODK forms. I create a ODK form on my end and then deploy that application on my mobile phone. Take that mobile phone elsewhere even without internet connection. I take the data, store it. The ODK allows me to store all those data in my mobile memory offline mode. And then later on, when you are connected to the internet, it can then get refreshed to your database. So this is another way that you can really track your real-time data using a small form, developing a small form through ODK. And in the ODK, there are a lot of data types that you can collect. One of them is location data type. So wherever you go with your mobile phone, just turn on your location, just take a location, take a point, it automatically takes longitude, latitude, altitude, all those 3 dimensions, and then you store it in a local mobile phone, because these days every mobile phone has got at least 1 or 2 GPS receiver in your mobile phone, smart mobile phone at least. So later on you can sync it with a real-time database and then visualize it or download it, whatever analysis you can do. That can be done with those things. As far as I've been using those techniques.
Yeah, Dr. Miyazaki wants to add something.
Yeah, and thank you very much for your support. And also I can perform some ideas. The real time is actually the very hard the specification to implement. While as he suggests several options, it depends on the applications. So the real time, it indicates every second or every hours or every day. It depends. Every second it's very hard. Every day it's possibly. So
I agree.
It depends on the problems, the applications.
Unless you have a data, unless you have an internet connection, GPRS or any internet connection in your mobile phone, the real time is almost impossible. But if you have that, yes, it can be done with the help of some tool.
Yeah, thank you so much. So I think we have less time now, and I'll ask the last question to Dr. Bhoj, and then I'll ask one more to Dr. Jackie. So to Dr. Bhoj, the world is still undergoing this pandemic, right? Like, although Thailand is probably doing better, but not all the countries probably, right? So how do you think these geospatial technologies can help combat such a pandemic?
Thank you for the most relevant questions of this year, I would say. Well, the main strategy to fight COVID for the last 1 year that we have seen since its outbreak in December 2019 has been to minimize the spread rather than any other things. We try to minimize its spread. So location-based lockdown has been one of the most important endeavors so far employed by many countries and have been one of the successful endeavor in it. So for this, calculation of the risk of traveling is very important. So the risk calculation of traveling might be different for different cities, different areas, different locations. That might not be same elsewhere. So before you make a travel, before you go from one place to another place, if you have a tool and technology where you can access the risk, that would be awesome. So on the same line, I would say we have started a research project and developed an application. We have launched it online as well. The application is called covira.info, where we have accessed the personal risk, the regional risk, and other few socioeconomic risks. So a person can access based on his behavior, based on his daily interactions, and based on the daily prevalences of COVID data on his province, on his prefecture, on his municipal, they can access the risk level and then make a decision. So that's one endeavor that I've been working for the last 8 or 9 months, and we have already developed an application on it. So we are going to make it a larger scale. But yes, that's the thing that we've been doing so far.
Okay, that's great. And this is for Nepal, few provinces, and
we have launched it globally.
Okay.
Even I have some test data from abroad, from some of the data I got from Africa. Some of them I've been getting from UK as well. So not much data are there. I think currently we have some more than 1,000 entries are there, but still most of them are from Nepal. But it's a global tool.
Okay, thank you so much.
You're
so
welcome.
my last question to Dr. Miyazaki. You talked about geospatial technology for community resilience, right? And as the last topic, can you please throw some light on geospatial technologies for pandemic resilient community planning?
Okay, so as I have the repeating, the geospatial technologies are local, and along with the localized such information, I believe the people could be connected. I can know of the neighbors, the detail more than before. So then it means that the neighbors could be connected, know each other very well. In case of the disasters, for example, one of the elder person next to my home has some problems with the legs. So that in case of the disasters, I could take a help. It's promoting the mutual help. So the mutual helps is important for some trust of the people, each other. Okay, so that in case if we have sufficient trust, then in case I'm infected and communicable diseases, I could say, sorry, I'm infected, and I would appreciate your assistance, something like that. Unfortunately, in Japan, some communities do not like to say I'm infected because he or she would be blamed. Little trust or mutual assistances. So my opinion, the geospatial technology for community resilience may help mutual assistances and those grow the trust of the people. Then in case, even in pandemic cases, the infected person could say, help me. So that's my answer.
Okay, thank you. Do we have time for one more question? There's one more question in the Facebook Live.
Yes, I would take that, Dr. Chitani.
Yeah, you want to answer that question?
Yeah, I think it's.
So the question is, the big
more
problem for data, especially in the GNSS and GIS context, is the privacy to solve problems like COVID-19. Do you have specific idea on how to better access information?
So I'll address it, and maybe Dr. Miyazaki would add something to it. So first of all, as Dr. Miyazaki just told, people do not want to come up, do not want to get exposed on their any sort of diseases. So even in my case, I was COVID-19 patient on, I would say, on the first 15,000 patients out of first 15,000 patients in Nepal. So for the 5th day, I exposed myself on Facebook Live, and I was very happy to see more than 10,000 people were watching it. So if we come up with that sort of things, the problem is solved. But as Sid Sheikh just mentioned over there, privacy is the big issue. Yeah, if I do not want to get exposed, that's fine. But still, we don't want people, we don't want to see who is infected. Rather, we can say which people from what place is infected. If we hide all the details, the specific detail, name, gender, or something like that of that person who is infected, then only expose all the information, the location-based information of the person who is infected, then it still serves our purpose. So I don't think that we need the specific person's name. Rather than hiding the personal detail, still we can get a lot of information, because we do not want to see the individual person. We want to see the trend. We want to see the direction it's going on. So I think privacy is not that a big issue when we address such type of things, geospatially. Dr. Miyazaki, if you have anything to add.
Thank you so much. So I think we can close now, although we have some questions in Zoom as well. Maybe Dr. Bhoj can answer maybe later on or privately or something, because we are running out.
Yeah, I'll do that.
So thank you so much, Dr. Miyazaki and Dr. Bhoj, for today's session. And it was indeed a very, I think, successful session. And then in this session only, I want to announce our next webinar, which will be on 3rd December, same time, 3 to 4 p.m. Can I share my screen, please, Dr. Samit? Yes, I'm allowed, right? Yeah. Okay. So our next webinar will be on 3rd December, time 3 to 4 p.m. It will be on INSAR, the magic of satellite interferometry. And our speaker is our very own, our assistant professor, Dr. Salvatore Verdis. He's from Italy. So I hope to see you all next webinar as well on 3rd December. Thank you so much for joining us today. Signing off, this is Dr. Chitrani Majumdar from Remote Sensing GIS Asian Institute of Technology. Thank you.
Thank you. Thank you very much for the invite, Dr. Chitrani. And thank you, EIT, for this opportunity.